Good, good, good.
Ah, c'est donc un dashboard.
Можно попробовать, но...
So my dream tool would be some kind of a dashboard for the project manager. Something that, when you log in the morning, pops up little indicators with gauges and I had made last summer a nice slide, and it takes time, to do a slide with nice graphics with a dashboard, but I lost that slide. Little story about configuration management, backup, and that kind of thing. When you do a backup, all of you do a backup. You have a backup of your machine? Sure. Okay. Don't leave the backup and the computer together. So in December, on December 5th, I was getting ready to go to Russia, and I thought, oh, I should do a full backup. Full backup takes 3 hours, I won't have time. Let me do it at home tonight. So I take the disk and I put it in my bag. And my bag is stolen in my car, so I had the computer and the backup disk. So since I'm a cautious guy, I had made a few CDs, I had burned a few CDs, but that was last July, so I've lost everything I've done from July till December. So among other things, a few slides. During the summer, I had some quiet days, so I sort of improving this course and created quite a few new slides with some graphics, which always takes a long time to do. Anyhow,
Maybe you can recall some ideas from that report.
Yeah, I recall the ideas. Unfortunately, there are things I had started to write a little book, and I've lost everything. So now, whenever I write something, I at least put it on a memory stick. So the dashboard, and my idea of a dashboard is it should be configurable. That is, a project manager should be able to evolve it over the course of a project or compose the dashboard. So you would have a little bit like the little gadgets that there are on the new Mac OS version. You have these little gadgets that you widgets. Okay. You could sort of compose your dashboard. So on the dashboard, I would have list of risks, maybe. So I would have something that is the beginning of the list of risks. And sometimes I separate risk and issues. Issues are not necessarily risks, but they are little things that popped up about which you need to do something. Somebody needs to do something soon. So they're not necessarily risks, but they are things that you need to not forget, otherwise the project will get into some issue. So that's two things. Defects. You probably don't need that at the beginning of the project because there's no defect at the beginning of the project. So this is one that you will have at some point in time. So you might have some curve that shows defect, and it's nicely trends to 0 there, so you're almost ready to deliver. The little graph that I showed yesterday, that is some kind the poor man version of an earned value system. This is called a burn down chart or a burned up chart, depending whether you go up or whether you go down. The one that I showed is a burn up chart because the curves go up, but some people do it the other way, where actually you reach 0 when you would be a nice one to have. This one you can start at the beginning of the project because you can also see scope creep. So it's useful to see. So we will have a burn up chart there, or burn down chart. So this would be, I would say, progress relative to the functionality that is to be included. That's effects. This is risks and issues. So what other things are useful from a project manager perspective? So you have your ideal staffing profile, you have the various milestones in the project, let's say there are phases or iteration. Very often project managers have done very nice hypotheses about we're going to be successful because we will have all these people on board, but unfortunately your HR people are not able to provide you with the right people. There are other project managers who are smarter, who can steal all the good people because their project is bigger, has more money, more priority, so you're constantly starved. Yes? You want to share a story? So,
yeah, in our company, program managers do the communication with recruiting.
with?
Program manager, next level of management.
Oh, yeah,
Program
okay.
manager, people, project managers are reporting to.
Which
So-
makes things a bit more interesting.
Okay. So sometimes the actual number of people, sometimes actually in most cases that I know of, the actual number of people seems to be always below what we had in mind, which is again a bad sign, which probably shows somehow on poor man's earned value system in terms of progress. But I found one little graph showing the dates, the key milestones, and the expected staffing profile with the actual staffing profile pretty useful. So this is what I meant by the open position. Open position, it's basically the delta here. And we may add some more. Do you have any ideas of other things you'd like to see?
I wonder why there is no milestone list. Is it in
That's
a
what I
burn?
mean
Is
here
it
by
in a burn?
these little triangles represent the milestone.
Yeah, but-
Yeah, but I mean, when we approach the milestone where we are now, and how good we are in approaching the milestones, is it what is contained in?
This is
in the
a
burn
kind of
list?
static graph.
We're
and
here.
Alexei is talking about milestones of the project, plan dates,
Dates.
planned date, original dates, currently planned dates,
Maybe buffers
actual
and so
dates,
on.
milestone slippage, or stuff like that. So more detailed information about how we pass
Yeah.
milestones, not just graph with and you said that this is a kind of hiring graph. So these are key milestones where you change your maybe hiring needs, stuff like that, and in the course of the project you will have much more milestones linked to just project events, not necessarily hiring needs.
So what I suggest, you have a little button here on each of the things that says, click here for more. Click here, and then you have something more substantial with more detail. What?
Maybe, but information about how we are passing milestones is for our experience, it's one of the most important information because it's how we meet our commitments to the customer. So I would prefer to have a kind of list on dashboard, not with no necessity to click. With indicators, this milestone passed, okay, this milestone was slippage 2 days, maybe some forecast for future milestones. If we anticipate some possible slippage, we can put this information there, and the indicator can be yellow, reminding us that we need to do some corrective actions, stuff like that. So it's about external commitments and customer
There's
satisfaction.
room for more widget. We can
Still
invent some.
some room, yeah.
Aren't that earned value graphs that useful?
That's what I meant there. Sorry, it doesn't look that sexy. I don't do it with. It's
What about iteration, some iteration information like iteration burn down? This is
sorry.
overall project burn down. What about iteration burn down?
Whichever you prefer.
Yeah. Okay. I don't. I'm not sure. I've never seen.
You've never seen one?
What does that second please represent?
You see your current iteration here.
Oh, there is
Why making one specific for an iteration?
How do you understand what is planned for the iteration by this chart? I don't see it. What is planned for, what features are you planning for iteration and how you are approaching the zero?
Okay, we're not looking at a dashboard now. You want to look at the whole information. There are other information than that available. Yes, there's the list of things that we're doing in this iteration. There's, you know, the cost of the effort associated with them. There's the name of the person who's doing it. You know, there is the time of the retrospective. It's Friday at 2 o'clock. There's all other information. I'm trying to have a little bit of synthetic.
So the general idea is that on the dashboard you would want to have a speedometer and then measure the lamp there. So
That kind of thing. Also maybe interesting to, so I agree with you that you need to know more tactically at some point in time, but it's nice to have, you know, the complete picture. If you only look at the you know, your narrow thing now tactically, after a while you lose track of what is the big picture.
Both are important, of course.
Yeah, but I'm not sure I would build a burn up chart or burn down chart for one iteration. I don't see the value, unless you have a very big project and very long iteration.
Might be good just to, well, this kind of information for the team of the project manager.
No, but knowing what we're doing into iteration, I don't know what you do. Use
You
a
can
wall,
understand
use
if
an
you are
Excel
doing-
spreadsheet, use a
can
wiki
get-
that has the actual list of the 17 user story we're doing in this iteration. But if you want to do that on a graph like that, it would already be far too populated. If you start indicating the name of the activity, the cost, the person allocated with it, the current status.
Well, it depends upon who you are. If you are a project manager, which is actually the customer for a team of people who do work for you, then it's probably not so important because it's their responsibility to make everything working for you. But if you are a kind of project manager for some external customer and you are committed to the iteration scope, then understanding if you are going to succeed in iteration is a very important thing, right?
Yeah.
That's why probably in that position you would like to have some burn down chart to understand if you're going to commit with the iteration scope or not. Which is mostly the case of Luxoft, and we are committed to the iteration scope rather than the whole scope of the project.
Okay. Point taken. I've just never done that on an iteration level. Other things. The status of the current build. There's a company in Seattle. They've bought an old traffic light. So they have, you know, the traffic light with the red, the yellow, the green on four sides, and it's hanging in the middle of the biggest room. And it's hooked to the computer where they're using cruise control or some tool like that. And on top of that, they have also an electronic version. So you can, I forgot the URL, but I could ask my son. You can actually see the state of the traffic light from wherever you are in the world. So you have a traffic light that indicates the current status of the build. The build is current build is okay. Add the name of the culprit when the thing turns red. Who broke the build? Okay, that's
Mozilla community uses similar thing. Mozilla community uses similar thing.
yeah, a lot of people use that. I don't know who started this. I have no clue. But the first time I saw a real traffic light, I found that very funny. I forgot the name of the company. It's the company where Leon Freeman Benson was working for a while in Seattle. A great company. There are from now on a lot of sections, but some of them I'll skip relatively rapidly. For several reasons, they sometimes are relevant only for some large projects. So I will not dive into that too much. This was a little bit my opportunity to place a pitch about software architecture and the role of software architect, but I've made that pitch on Monday night to some of you. Here there is a lot of information about how configuration management work, what's the underlying principle, but I guess with this audience I can skip most of that. You should, I assume you understand the value of configuration management and how it works. Here I'll need some of your feedback. There are a few things that people in other audience do not know about open source. So I'll spend a little bit of time, but we can discuss about it. This I removed almost completely because the idea is that sometimes I've seen relatively junior people focusing solely on the software and working executable and forgetting about all of the other issues that constitute a product. That's very often the case when you have, people who are mostly software designers and programmers, and they forgot issues about packaging, about installation, about support, about internationalization and localization and all those things, and they discover them late into the project, where some of those things need to be planned very early on because they take a long time to achieve. And it's more than just writing one user story. Need a version in Japanese. It's actually, this one will probably trigger a dozen user story in itself. Because there are some impact on the architecture, there are some impact on the choice of tools, there are some impact on gathering all the text, there are some, probably need to hire some people to translate things, some people to review things. It has some impact on testing because you need to redo the testing with the localized version because bad thing may happen, although you think you've only translated a few texts. So it has some relatively nasty consequences. I've seen projects where people thought, we're done. And actually there was quite a lot of stuff to do to finish, to have a complete product. But okay, I've decided not to deal too much in that. Here, managing people, this, as I said, is very, sometimes very culture or country specific. But since you're working with a lot of other countries, it might be interesting to go through that and discuss that and see the differences and, that exist. So I'll take in that course I take a North American perspective. I've worked in the US and in Canada, but remember that I come from France, so it's a little bit of a blend between Western Europe. And I noticed some subtle differences between the two. And then there's a whole section about culture, and that there's a few things that you may have noticed or not, but people behave and work very, very differently when you go around the world. And when you have projects that straddle across the world, there's all kind of mishap and incidents that are very, very puzzling. So I'll dig a little bit into that if you're interested. I'll look a little bit about this and a little bit about this, so we won't do much. And we'll try to complete the dashboard. If, okay, so what I meant by managing complexity and why is that important to the project manager. Some projects have some inherent technical complexity. I'm speaking about the technical complexity, not the complexity because there's many people or that kind of thing. That's another aspect. In particular, some projects need a lot of invention from a technical perspective. It's not a standard solution. We're going to use client server with no operating system, and it's classical framework like .NET or J2E or something like that, or Corpa, and we're just going to pop up some stuff on top of it. Sometimes there are problems a little bit more challenging, and you may have to dedicate a big chunk of your activity to actually putting in place the right skeleton, the right bones for your system. If you're doing some embedded stuff in transportation, I have friends who work on an automatic train, a train that has no driver. It's not your standard client-server web-based stuff with some JavaScript, HTML, Ajax kind of thing. It's a totally different architecture. There are little computers alongside the tracks. There are transmitters from the rail cars. There's all kind of safety device that need to be worked out. It's something new. You cannot find an architecture existing and say, okay, let's start to write the code. So these kind of issues require quite a lot of effort that is not related to what we see traditionally in the agile literature. There are very few user stories. Actually, there is one: get the train running. That's about it. You know, most of the user story, if you want, most of the functionality is relatively hidden, doesn't face any human being. Is time related, event related, so it requires quite some work that is very, very different in nature than what you have in a more traditional MIS system. So a lot of the complexity, the risk, the unknowns will be tackled preferably early in the project. It's not something that you can just easily refactor towards the end. And this is where I had some very interesting discussion over a long lunch with Ken Beck, and he realized that I come from a totally different world than the world he comes from. And when he tells me, oh, we just need a simple metaphor, and that's all what we need about architecture, and we'll just do some refactoring, it says, well, the world I come from, that wouldn't work. You cannot just say, we need a simple metaphor, and let's start writing the code and deliver value. There's also very often the type of project where there is no incremental delivery. You have to develop everything before you can actually start installing. There's no partial implementation. You know, so let's do a little bit of it. You know, let's do the software that is in the rail car, and we'll do the one along the track later on, and we'll do only half of the central control. No, you have to have everything before you can actually deliver. Okay, so software architecture. I'm sorry, I don't know who was there on Monday. Maybe I don't need to repeat all that. Were you most of you there on Monday? Maybe you were not there. Complexity arises from sometimes a large number of requirements. The biggest system I worked in terms of measuring requirements at 800 use cases. And we're not speaking about tiny little use case that fit on a quarter of a page. This is sometimes an indication of there will be some technical complexity. It's not 800 use cases where each one of them correspond to some boundary class and a couple of entity class and some access to a database communicating over the net. They're not all 800s like that. Some of them will trigger some complexity. It's usually when you have many hard non-functional requirements that complexity arises. It's the total amount of functionality is not a clear indicator. Embedded software that have some, for instance, real-time performance associated with them, you know, some very hard deadline. Things must be done every 120 milliseconds. Absolutely in all circumstances, you cannot miss a beat. Things that needs to have very high availability. The last telephone switch I worked on had availability sorry, requirement of no less than 30 seconds per year of downtime. So basically, that thing would never stop. That's what it means. Maybe 1 out of 100 switch would sometimes completely stop. That's roughly what it means. It means that this is stuff that is maintained live. Actually, I took some very bad habit when I was working on that switch, because we would take a CPU and just pull it out and change something on it and put it back in on a live system, not turning the electricity off or anything. The system would reconfigure itself, the rest of the software would find it, and it would go back in place. Same thing, take some memory out, some interface out, pretty amazing stuff. And I took so much bad habits is that one day I came back at home and there was a problem in my PC, and I opened the thing and I pulled a board out, and sure enough, the whole motherboard died. That's how it takes sometimes some bad habit working with high availability stuff. And when there are some safety critical stuff, you know, things. I was reading in the taxi this morning about I don't know if you know the Center for Nuclear Reprocessing that's in France, somewhere in Normandy and in La Hague. I've been involved with one of the French nuclear power plant. It's a pretty challenging type of software to work with that kind of thing. Sometimes high complexity arises from a totally different issue. If you have a large amount of legacy software and you need to evolve that software with some continuity, that is, you cannot rewrite it from scratch, and you have to reuse chunk of the existing software and gradually bring it back. It's actually technically pretty challenging. It's ugly stuff to do, but there's some interesting challenges. Sometimes the complexity is created by the fact that there are multiple parties involved. Very large project. Actually they are involved. There's a very large project going on in the US called the Future Combat System. A lot of the technical complexity, in my opinion, is generated by the fact that they have far too many contractors, who have far too many smart people, who have far too many competing solutions that they want to work together. So that's, I would say, create unnecessary complexity. But okay, that's the way Boeing and the US government have decided to proceed. Little anecdote, that project is so crazy, I decided to stop being a consultant for them. I was just getting tired. It was sort of depressing to work there. What is software architecture? Software architecture, it's, you know, how do we organize the software? What are the ways to decouple it, organize it in chunks? So it's mostly about the organization of a software system, and by organization, very often people speak about structural components, either on a static view, the chunk of software that you use, on a dynamic view, what are the processes that are running concurrently and how do those processes communicate with each other. When the software is deployed, what are the processes that and how the processes communicate together. So architecture will not focus on what's inside the blobs of software, but more on the interfaces and the logic by which they are assembled. Very often people focus only on the structural element, but there are a lot of issues about the overall behavior, the runtime behavior of the system, which is going a little bit more than just structural. In very large systems, there is issues of composition and decomposition. That is, this is sort of recursive or hierarchical. There are issues of style in order for an architecture to be easy to understand, and this might rejoin the concept of metaphor in XP. Issues of style, trying to define some systematic and uniform way to organize the architecture. Not taking too many technical solutions and try to cram them together, but try to find a few architectural patterns and try to exploit them systematically so that there is some uniformity. If you need to come up with a new feature or some new functionality, you will replicate existing patterns rather than invent new things. So the concept of style is sometimes important to get uniformity. And this uniformity, there's an old principle of software designer, I don't know if it evokes something for you, what I call the minimal surprise principle. When somebody arrives in a project and understands the typical ways of organizing things, you don't want to be surprised that suddenly somewhere it's organized totally differently. The naming conventions are different, the mechanisms that they use are different. You don't want to have, for instance, if you have something that manages time, virtual time or logical time relative to real time, you don't want to have some mechanisms that are used in most of the system, and then suddenly you discover that another mechanism is used there. So uniformity in a large software system is sort of important in terms of being able to maintain it and evolve it. Software architecture, yes, focuses on structure and behavior, but is also how the system is being used, what type of functionality we're going to graft on the system now and later, performance, resilience. Resilience means will it break rapidly when we try to make it evolve? Reuse, and that can go very far, the concept of product line. Is it easy to understand? And architecture has also to do some trade-offs with economical and technological constraints, because some solution may be too expensive or too hard to put in place relative to the kind of people that you have to do the development. In the late 80s and beginning of the 90s, a bunch of people at Rational Software who were working on relatively large systems, we developed some concept to describe an architecture. What we came to realize at the time is that it's very hard to represent an architecture with one single flat blueprint. that software architecture is a relatively complicated thing and that there's multiple structures that coexist in the software. And we can argue about how many of such structure there are, and you might have 2, 3, 4, 6, 7. We agreed on these 4, and then we added a 5th. There's one view of the software architecture, which is the nice, clean designer's view, where elements that you represent are things, if you're using object-oriented design, things like classes. You have a class hierarchy, you have classes that use each other, classes that derive from other classes, and so on. So you can have a relatively clean definition of your software using the concept of class and objects. Most of the functionality will map on the concept of class and objects. But classes and objects, if you develop your software, may map relatively cleanly to the various files that you have on your development system. And in simple system, there's a one-to-one mapping. I have on my design one class, and I will see in my source code one file that contains that class. But unfortunately, on large system, it doesn't get clean like that all the way up. You want to reuse code that exists already, that's written in another programming language that may not have the concept of class. You use some components that for which you have only an API, but you don't have their design. There's all kind of things that make your logical view, which is nice, neat, and your physical view, if you want, what you see on the compilation system, somewhat different. And also, there's some other issue that pops up. Issues such as variance, issues such as release, all the issues related to configuration management. How do we manage variant by country, variant by functionality, variant by the system into which the system is deployed, and so on. So we separated the logical view from the sort of component or development view. On simple systems, then the software that runs on this machine runs usually using 1, 2, maybe 3 processes. And it doesn't really matter that much if you understand what exactly are the role of those processes. But in large distributed system, there might be a lot of concurrent processes. And this structure is completely orthogonal to the concept of class. That is, you don't have one class, one process. You don't have many classes run into one process, or you could have that, but sometimes you have many processes that runs object concurrently from one class. So there is no nice one-to-one correspondence. And unfortunately, I found that unless you look in real-time design, real-time software design, most design books are pretty, don't say much about concurrency, process, communication between processes, and things like that. And a lot of software designers sort of tend to ignore that until very, very late. That is, until they get into some nasty issue. So that's another view on the software, the view from a concurrency perspective. What are the types of processes? How do those processes communicate? How do we partition or allocate CPU between those processes? How do we manage priorities between processes? How do we avoid issues such as deadlock and starvation? Issues that have been studied, 30 years ago, but for some reason they reappear nowadays. I don't know, maybe this is not taught in school anymore, but I realize that people come with some strange problem. They have things distributed over the net, And they say, well, it behaves very strangely and things block. And we studied it, and I say, hey guys, what you have is a classical deadlock. Oh, yeah, what's that? So there's certain issues related to performance, scalability, throughput, that can be studied from the perspective of the process view. And again, in large distributed systems, there's the issue of deployment. Which piece of software will reside on which piece of hardware? In which order do they start? How do they recognize each other? If you have highly redundant system, what are the primary system? What are the failover system? What's the communication between the primary and the failover? How do you synchronize data between multiple systems and so on? So this is where the software will, in some sense, hit the hardware, the deployment view. What are the various computing nodes, and which processes run on which computing nodes, which in turn will tell you which pieces of software will actually be deployed on various nodes. And this can become pretty sophisticated. There are systems where the software automatically migrates with failures of some processes. That is, there's a lot of software in the underlying architecture that observes the environment and makes some decision about migrating some functionality from pieces of hardware to other pieces of hardware. I mentioned to you a few times software in a submarine. In that submarine, just as an example, there is no central computer. The computers are spread all across the submarine, and there's a sort of three fiber optic nets that go across, following different paths in the submarine. And the functionality can run on many of those computers, and if some computers are destroyed, the functionality is gradually reduced and migrates towards the remaining working computers. So again, some interesting user stories.
Yes.
So such systems, there is a lot of non-user-facing functionality, software that needs to be put in place, and building a skeleton of it that needs to be developed. And this is happening mostly around here in the lab, around this elaboration phase. For more traditional system, when you have a sort of de facto implicit architecture that speaks during inception, when you say, well, this is the classical client-server, two-tier system using some MySQL database or Oracle or something like that, and where the architectural choices are: do we have a thick client or a thin client? This is pretty much contracted, and most of the project will be in sort of construction in the transition. From the project manager perspective, my recommendation is to align the organization with the architecture and not the reverse. You know Conway's law? Conway is an old guy. He's older than Mikhail and myself. He did software in the 60s and 70s, and he was already pretty famous when I was in school. So he was famous not for Conway's law, he was famous for having invented something that he called life. It was a sort of strange little automaton that some configuration would trigger something. And we wasted a lot of paper when I was a kid trying to find some other gliders, as we call them. Anyhow, Conway's noticed the following thing. He said, if for a given programming language, if you give it to an organization that is organized in two teams, guess what? You get a two-pass compiler. But for the same language, if you, in another company, if you give it to an organization where people are in three teams, because there are three parts of the building, by miracle, you get a 3-pass compiler. So, very often, if you have an a priori organization or grouping of people, very often your architecture will sort of mimic that organization. And it's not necessarily the best structure that you can have for your software. You end up having an unnecessary constraint on your architecture because you have this a priori organization in team. Some of you were there on Monday when I described a funny thing that has happened to me. There was a big project, and that big project, the prime contractor here, the organization that received the huge contract from the government, decided to get some help. Actually, one of the reasons they got the contract is that they had committed to get some help from the local country. So they had five other organizations that said, we're going to help. And these 5 organizations said, oh, we're going to take, the GUI part. We're going to take the communication part. We're going to take the training simulator part, and so on. And this organization in 5 teams created some kind of a software architecture. People thought, we're going to develop 5 blobs of software. Each of those 5 blobs will have its own design, and at some point in time, we'll try to make it work together. And this created the most absurd software design I've ever seen in my life. Because the same class, for instance, was rediscovered in 3 of those teams. And another class was recognized in 4 of those teams, with totally different design, totally different attributes, sometimes even totally different names. So it was really, really weird. Anyhow, to make a long story short, it's better to first define an architecture, identify the chunks of software, and then create teams along those blobs of software, rather than first define the team and then try to think that each team will be more or less autonomous and do things. So the best is to have no idea a priori as to organization in teams. And so what this makes is create some additional function in the project, which is an architectural function that may exist for maybe only part of the life cycle, and have an architect, or in the case of a large team, an architecture team that will tackle this. And this is a different function from the project manager. And there are some subtle interplay between the architect and the project manager. In a very small team, and especially when there are few architectural decisions to be made, while if your project manager happens to be also the most senior, talented, technical guy, he can play both roles. But in a very large team, it's a very bad idea to have the project manager be at the same time the chief architect. Because both are a full-time job, and you end up doing a relatively crappy job if you try to do both things at the same time. On the other hand, they cannot operate independently from each other. They actually have to speak to each other pretty often, and it's even best if their offices are not too far apart. Let's skip the various metaphors, we can discuss that some other time. So, in a large team, the architecture, it's not something that is external to the project, it's not some kind of a think tank of people in an ivory tower. They are part of the software development. You may have different subsystems with some developers. Well, the architecture team is just one other such team, and if there's only one architect, it's there. So it's not something that is separated. It's not the boss of all the other teams. one of the team.
Okay.
Yeah.
I have a question. And where is a system of business analysts, which knows the business domain of the system? Are they in architecture group or something else?
No, well, again, it would depend on the size of the project. The architect have to be strongly connected, especially in the early days of the project with the analyst. But depending on your organization, you may have different analysts in different teams. For instance, if this is a functional area, it may be the case that the analyst is associated with that functional area, and another analyst for another functional area. Or you may have just another team here. But since they need to be in close contact with other people, so again the same thing. Don't make them too separate. Yeah.
A model-driven architecture. Can this methodology or concept help to manage project?
Does model-driven architecture
Yeah,
helps
to manage project or help only architect team to manage complexity? Model-driven architecture, model-driven development.
Yeah. I'm a bit skeptical about model-driven architecture. I don't think this is a technology that has proven itself yet. So there's a lot of things being written and said about it, but yeah, it's not something that you're going to do in a distributed fashion. You need a few architects to drive it. I don't know what to answer to the question. I pass. I know only one company in Israel that I've been working with, and they're good friends of mine who have been very successful using model-driven architecture. For the rest, I hear a lot of hype about it, including my former employer IBM. I don't know. What's your experience?
This beautiful idea is not matured.
Yeah, it's not mature enough.
I have a question. Here we have one project lead, and if we have teams divided into different cities, and shall we have personal team lead for each subsystem, or maybe we have one super project lead for all systems, all subsystems?
I need to parse that out. There's too many variables in your question.
In this picture, we divided system up. We fixed the architecture, so we found several teams for each subsystem. Each team have one or several subsystems.
Yeah.
And now we want to manage them. And unfortunately, these teams sit in different cities.
Yeah.
Okay. Shall we have one team lead for each team and one super team, super project manager?
Okay. So we have these people in Moscow and these people in Kiev.
Yes.
And there is a project lead here. And the architect, unfortunately, has to be one of the city. Well, you'll probably have to go to Kiev a few times a year and speak with the people in Kiev every other day. But that may not be your question.
The question was about project management.
Yes, project management.
You don't want to have
Should we
two
have
project managers, this stuff.
Should
How
we
much
have
project managers should we have for this
One.
kind of situation?
and maybe
Some team
one.
leads, right? For each team?
Okay. So let's say B is in Kiev.
Mhm.
Well, there is a lead there. That the lead of that team better communicate with that guy, probably daily. But don't. If you start having two project managers that are sort of peers, that start to be a bit complicated. It might work nicely when there's no issue, but when issues start to pop up, I don't know. I wouldn't go that route.
And maybe one project lead can manage all these
Now-
teams.
You mean one project lead can manage all teams?
Yes.
I'm not sure.
Without one project lead from Moscow manage teams in Kiev, Moscow, and
Most
maybe
probably the question is, should we have local team leads or it's...
No, you should have local team leads. I don't believe in the team lead that's in one city and all the people is working with in another city. That doesn't work too well. Maybe when technology will have evolved to the point where we have almost seamless thing, we see our friends in Kiev on big screens there, we just speak to them, hey Joe, what do you think about this? When we could have a daily stand-up meeting where we see them. But okay, we're not there yet. For 4 years, half of my team was in Sweden. But in order to make it work, I would spend 1 week a month in Sweden. And we would meet with video. We had a meeting rooms, a TV screen, a little video camera between Vancouver and Stockholm. And despite this, the fact that we were meeting regularly, the fact that we saw each other, the fact that the Stockholm team would come to Canada to do some skiing with the Vancouver team, there was constantly some little misunderstanding. Constantly. Week after week after week, there was some overlap, things not being done, things that some team member thought the other team was supposed to do. It was very, very hard to manage, despite the fact that we had some relatively comfortable net communication and even video. I'll come back to that later. The video was important because I had very, very vocal, animated people in Vancouver, and the Swedes were. So having video, sometimes when we started, I was wondering, is there somebody in the room? Or was I here in Stockholm like there? So at least with the camera, we could see that they were there. Yeah, they're not the most vocal people in the world. Yes.
Another question: who defines the subsystems? Who defines the scope of each subsystem? Architect or analyst? Or analyst subsystems and architectural subsystems is differently not the same?
Yeah, I would focus on where the code will be and define teams around big chunk of code. So it's not an analysis thing. It's mostly a code to be developed kind of issue that will drive the organization of team.
So for some cases you don't see the role of analyst, specific educated analyst working on a constant basis in a team.
Why? Did I say something like that? Okay, the point of this diagram is not to say this is the ideal project and all your projects are like that and the analyst sits somewhere. The point I was making here is that the architect is one of the team. That's the only point I'm trying to make there. So don't read too much in that. I'm not saying that the ideal team has 3 subsystems and one is tiny. Don't read too much in this diagram.
Things are even more worse if we have not only separate teams within the same organization, but when we have separate organizations, when we have subcontractors. How can we manage those subcontractors? Should we try to?
Can we postpone that when we speak about organization? Because I'm just trying to speak about architecture. Okay, so ask me again later on, and I may not have the answer, but I was just trying to make a very small point here: is that the architect, it's not another organization sitting somewhere else. It's part of the team, and the architect report to the project lead, or to the project manager. That's the only point I'm trying to make here. And the architect has to communicate with all these people. And it's better if the architects sit in the middle of the team. Their cubicle is there. They're not in another building or something like that. What I've noticed now more and more, and recently on 2 big projects that actually failed, for relatively challenging system, not simple little system, but relatively challenging system, there is not enough emphasis in agile method, both XP and FDD on architecture. They presuppose the existence of an architecture, and yes, when you have an architecture, that architecture is known and stable, yes, you can relatively rapidly add features, deliver functionality. But in my opinion, the architecture will not emerge as a matter of weekly refactoring. Rapidly, you will have accumulated a lot of functionality, and you will hit a wall from the perspective of the architecture, some of the performance of the system and things like that. So, just a word of warning.
So it means that we have to collect enough requirements to have some architecture requirements.
Yeah, you need to try to derive, to have some feel for how much derived architectural requirement you will have in this project. And it's not so much the functionality that we derive that some of the non-functional requirements or some of the requirements about capacity, size, availability, security, these kind of things will drive some significant work on the architecture.
So I can start my work for relatively complex systems by having sort of, not a waterfall, but some iterative, more complex development with the architecture teams and so on and so forth. Until I found that
this is exactly what the elaboration phase in web is about. It's doing iteratively, building a skeleton of the system, onto which after that in construction you can happily bring the hordes of programmer and plug all the functionality.
So in construction phase I'm going to have some kind of XP with all this practice in place, right?
Yeah. XP would work pretty well there.
Okay, great.
But XP would work very well in the elaboration phase, except you're not trying to deliver any value to any outside customer out there.
Mm-hmm.
You're trying to put in place enough of the bones of the system so that you can have the performance, the load sharing, the availability, the automatic startup and recovery when a processor fails, and all that kind of thing.
So this is looks like Scrum, ideas from Scrum, or early Scrum days when they said that there's some kind of waterfall things at the beginning and in the end. In the beginning when I try to invent architecture, in the end when I try to deploy to some customers.
Yeah, I'm not sure that this is really waterfall. You can do that iteratively.
Well,
the problem is sometimes there are technical issues that are pretty complicated that would not allow you to iterate very, very rapidly. You may not be able to do one iteration a week. It may be a little bit longer because there are some relatively delicate, complex things to do. So, but it's not, I wouldn't suggest to do that in a waterfall fashion.
Okay.
Not a good idea. You need to get rapidly to code that runs.
So I'm
To
building
validate your ideas and build some test harness. So build the test harness early. You know, if we need something that supports 2,000 simultaneous users and has automatic failover to a backup database, build 2 servers with a backup database and a load with 2,000 stupid things that just do some busy stuff to see that you have it in place and that it works.
Okay, but the main message is they can use, for example, some kind of Scrum, but create enough attention to architectural issues.
Yeah.
Build first
A skeleton,
architectural,
sort of a
right.
skeleton of the system. If you don't want to use the word prototype, People sometimes understand prototype, it's something quick and dirty that you throw away. But that's not what I mean in architecture. I mean an evolutionary structural prototype. And build specific tests for it. And they're relatively complicated to write those tests. You know, if you want to build some tests that test what happens in case of failure, that measure timing for recovery from the primary processor to the secondary processor, it's not that easy to do. It's pretty challenging. But none of that has functionality facing the user. What I suggest is to take a few very critical functions and as an illustration to make sure that we understand the whole path. Create some very long path to the system just to exercise your architecture. Let me give you an example. When we were doing some brand new architecture for a new type of telephone switch, a highly modular telephone switch that would go from 100 subscribers to several thousand subscribers for companies. We derived the architecture, we put the skeleton, but we tried to, at any point in time, during the iteration for our architecture, to make sure that we could do one phone call. So that the designers would not forget what is the primary function of a telephone switch. Because you don't want to build a fantastic architecture completely forgetting what ultimately the thing has to do very well. So we took the primary function of a telephone switch, which is to establish point-to-point communication, and we were making sure at every stage in building the architecture that we could still do the point-to-point phone call. And actually, you know, I'm not joking, on a Friday afternoon after we finished an iteration, we would actually call the boss. He would come down from the 3rd floor and he would say, this is our new stuff. So there was lots of ugly hardware with wires and things like that. He would say, dial, phone calls, the guy at the other end said, hello. And then we would open the beer. It was a little bit the equivalent of the traffic light, if you want. So don't forget, ultimately you have to deliver some functionality. So I'm not saying that this elaboration phase, you completely ignore the functionality. It needs to be constantly present in your mind. Which functionality will graft onto that? So pick a few of that functionality and make it part of your iteration objective to have that functionality present. In that case, we were doing more than that. Not only we would do a phone call to impress the boss and show some progress, but we would also have a machine that would generate, 600 phone calls per minute and see if the switch was taking the load. Okay, I'm deriving. So that's some of the things that the agilistas need to remember. For large system, architecture will not just come up out of... Okay. All systems have an architecture. Most systems have an implicit architecture that exists already on day one, that seems to be understood by everybody, even if nobody even used the word architecture, but it seems to be obvious. Sometimes it's not obvious, and sometimes it represents maybe a quarter or a third of the project to put in place and validate by testing and inspection and other things like that on architecture. The project manager needs to understand the role of architecture and exploit it first to align the organization with the architecture, to drive the early phases, especially this elaboration phase, which is not producing user-facing functionality. Need to mitigate the technical risk. A lot of the technical risks are related to which architectural decision you're going to make, which technology you're going to embed, how you're going to interface things, what kind of technology you're going to use to validate your architectural choice and so on. So you'd like at the end of elaboration to have most of your technical risk crossed out, so that precisely you can comfortably just add up functionality day after day. Define a rhythm for iterative development, articulate reuse, yes. Part of the work of the architect is to see which chunk we're going to reuse, how we're going to reuse it, which components are going to be developed and maybe used in different parts of the system and so on. And I spoke to you about the fact that I think beyond 15 people, probably this needs clearly to be two distinct persons playing this role. Should we have a little break? Yeah, it's about time. Manage complexity, but part of that management he delegates to the architect when the team is large enough. Managing changes. There's numerous kind of changes, not only the ones that Ashcat embraces. There are all these external changes that changes the environment of the project, which needs to be managed, filtered, acknowledged, incorporated in the software. And there's all the changes in all the artifacts that we're producing. And actually the two have to meet somewhere. So there's a lot of slides in there about software configuration management, and the reason there's a lot of slides about that is that I've run into organization where software project managers did not know anything about configuration management. They had no clue. They thought, oh, this is some ugly stuff that programmers do. And although they knew about software programming and that kind of thing, and had themselves developed software, their notion of configuration management was pretty tenuous. So configuration management, there's standards about that. It existed for a long time. There's zillions of tools that do that. And it has to be sort of adjusted with the notion of change and controlling change, knowing when there are change, what's the impact of change, when a change has been taken into account, and all that kind of thing. So this is why in the RUP the two are really linked. We speak about configuration and change management, which doesn't mean that all changes appear in some way in configuration management. There are changes that are done to the project that have nothing to do with changing an artifact. So a nice definition from our friend Steve McConnell's, some key definition of SCM, identification, control, status, audit. The jargon is inherited from hardware manufacturing. Configuration management was not invented by software people. In the early 70s, when I started to work on very rudimentary configuration management, we were just trying to mimic what people were doing in hardware manufacturing by putting pieces together. So we speak about configuration item, which are the elements, a configuration, which is a set of configuration item. Configuration item have versions. A configuration is a set of versions, one version for each configuration item. There's the concept of history. As elements evolve, they have a history. There's the concept of baseline. Baseline are specific configuration that we want to remember because we want to compare to a certain baseline or because they have some value. In particular, what we release is a baseline. Let's speak through things. There are, however, some differences between configuration management done by hardware and done by software. We can share things. In hardware, it's a pure tree. If you have two wheels, the front left wheel and the front right wheel, it's not twice the same wheel. But in software, we have some strange issues that an item may appear more than once in the tree. Therefore, they're not really trees anymore. But we go along with that. The tools that we use understand the fact that it's not a pure tree. So we have some software that is decomposed into software. The relationship is made of, and U is made of X and Y is made of YA and YB. But it may happen that W is made up of Z and Y and YB. So YB appears twice in the tree, which creates some little funny problems sometimes. In software, we have sometimes multiple artifacts, so we have more than one tree. We have what we call a forest. And again, we may share elements in between two such trees. We have share items. So that's the case of two projects that are sharing some component. What is important is to understand the impact when you change something somewhere in the tree. It has some impact on going up in the tree. So if you change this, it impacts this, this, and this, but doesn't impact this. No big deal there. If we change this one, since this element is shared, there are in fact more things that are affected. Now, the relationship that we have in software is different than the one we have in hardware. The relationship is made of can take different shape in software. If you have a file A that includes a file B with an include directive, for instance, what we have in C and C++, for instance. If you have a file A that refers to definitions that are in another file, even if it's not by an include. But there's other thing. If A is the result of compiling B, so you would say is made of is a little bit strange, but if A is the result of compiling B, we have such a difference. If A includes bits of B by linking, when you take the result of compilation and you link them together, then it's also is made of. More and more we see tools that generate software. So software is, you have some configuration file or some XML file, and you have a little tool that parses it and generates some other file. That's another is made of relationship. So the next few slides explain, this is my few slides, software configuration management explained to kindergarten people. So we have items. Very often the naive programmer just sees this. He sees one item and changes it. And I've seen even medium-sized projects that were never more sophisticated than this. Everybody was working on the source code, and once in a while configuration management consisted in, oh, I put everything in a zip disk and I put the zip disk in my drawer. Which is basically making a copy of this and putting it in the drawer. So when we're using configuration management techniques, items evolve. That is, when I do a change in X, I create a new version of X, and then a new version of X, and then a new version of X. So this represents the history of the evolution of X. It might be interesting, actually, sometimes to revert to some earlier version. So a good configuration management system would keep the various version around so that you can revert to a new version in case you've shot yourself in the foot or something like that. And the various elements will evolve at different rhythms. So they have each one their own history. So what is a configuration? A configuration is a set where we have one representative of each of the elements, but we have only one version of it. So this is a configuration. That great thing is a configuration. It picks one version for each of the elements that are for each of the configuration items. This is another configuration. Are they valid configuration? They run, I don't know, it doesn't matter. They're both configuration. A baseline is a configuration that we've identified, and usually we give it a name, and so that we can speak in terms of differences relative to that baseline. So here I would say this is my baseline, and then there will be some evolution over time for a while. And at some point in time, I might decide to create another baseline. Another important concept, it's a consistent change. A consistent change is when I need to do a change in one element, but that change will work from a software perspective only if there is a corresponding change in another element. So those two things were working together, and those two things I need to have both changes together in order for it to work. After that, I can continue to evolve the green one. Will it work? I don't know. That's another question. But when I create a configuration to have a valid, consistent configuration, I need to keep together elements like this or later version. So this has as an impact that there are configurations that are valid relative to consistent changes or change sets, and there are configurations that are invalid. So is this a valid configuration? Maybe, hopefully. Exactly. We don't know. Is this a valid configuration? Relative to white and green, yes, it's a valid configuration because it contains both. Is this a valid configuration? Certainly not, because since it picked this one and didn't pick this one, this is an invalid configuration. No, you're skeptical.
No. Because if the white one depends on the green one, this is not valid.
It's a consistent change. You need to have all the things together or not. The yellow one is more, I think, what you think. The yellow one, it's probably valid because it contains a later version of it, unless what you've done here was destroying what made that a consistent change. So this one certainly not, and this one maybe.
What does white frame represent? Is it a change set?
This is a change set. This is change that have to be kept together. For instance, you valid a parameter in a procedure here, and here you're calling that thing with an additional parameter. That's typical simple example. So at some point in time, after things have evolved, you may want to create a new baseline. Old-time configuration management system would then discard intermediate version. But that was mostly because this space was expensive. 1 megabyte was a miracle. Pretty big thing, and so we would save space. Nowadays, it doesn't really matter. We can keep all versions. So there is no incentive to create baseline in order to save space. But we create baseline because we want to have a reference point. This is what was tested last night. This is what was sent to the other team in Kiev. Or this is what this is our candidate release for the release to the customer. So there are ways to identify it. So baseline, an inventory of a set of versions for a set of configuration items. They're identifiable and reproducible. That is, one of the ideas behind baseline is that when things go wrong much later and we have some bugs to analyze, we'll be able to reproduce that configuration, that baseline, and run some tests on that baseline. But it's also a reference point for future evolution. You can say, between this baseline and this baseline, what we've done is implement this feature, that feature, that feature. This user story, that user story has been done, this bug has been fixed, something like that. So we can identify work in between two baselines. And say this baseline contains this bug fix, this functionality, and so on. Now, where things start to be a little bit more complicated is branching. People want to be able to work in parallel, or people want to create different variants. I purposely don't use the word version because it's tempting. Different variants of the same software. So here, the red thing, I want to be able to split it in two, and I want to have two parallel histories. I want to be able to evolve it one way and to evolve it another way, and even to create configuration now that would have different elements. All the rest identical, but two different versions on two parallel paths for the red one. So what do we want? Why do we want to do that? You want to try a fix, you want to add a new functionality, and you don't want to step on each other's feet. That's the primary thing. This team here has to work on a variant for the North American market, while this team has to work on a variant for the European market. So this is a branching where you actually don't intend necessarily to converge at some point in time, which is a little bit, has some consequences later on, because there's all kind of nasty things that will happen when we want to have fixes. So, in the simple case, once you're done and happy with what you've done in your bug fix, and when you finish with adding the functionality, you want to be able to merge them. That is, we want the fix and the new functionality. We don't want only the fix or only the new functionality. So there's a delicate operation here, which is merging things. And tool will help you to merge things, noticing that there is no overlap. Whatever you've changed and whatever you've changed doesn't seem to touch each other. Doesn't seem to touch each other, but it may do it. And sometimes the tool will say there's a collision, and some human being will have to, basically the two of you will have to sit down and agree on how to delicately resolve the little conflict. And hopefully you've come up with something that contains the bug fix and the new functionality, and then you create a new baseline. So, in order for this to work, and to avoid people stepping on each other's feet, there is some very simple mechanism called check-in, check-out, by analogy, checking out a book in the library and checking it back in when you come back and you're done with the book. While you have the book at home, nobody can actually read the book because you have it. So this simple analogy is used to resolve conflict of access. And if this is where it's, the miracle of software, if Alexei has checked out something and you want to work on the same thing, you say down, he's checked out the thing, but it's not a physical book, it's a software book, so you can branch out. That is, you create a clone, and now you have your own checkout. So we also use that notion of check-in, check-out to identify who's playing with whatever it is, software, requirement, use case, plan. So we identify the fact that Alexei has checked it out, and then later on you would check it back in, and that you've checked it out and checked it back in. Moreover, when we are the sort of more rigorous level 3 CMM organization, you would justify why you've checked it out, and when you check it back in, you would say what you've done with it, and whether it's been tested and things like that, and point to which user story or requirement or defect it's associated with. So we have a little bit of a trace and a history of what happens in the project. So checkout, modification plus check-in, that's what creates a new version. So basically when we look at the software at any point in time, we can know what has happened to it. And this is very helpful to understand how we created problems, go back to the root of the problem, find out what Joe was doing before going on vacation and leaving a mess. So we would check all the things that Joe was doing on the last Friday before he left. And there's all kind of things that we can do. We can also do nasty things like look at all the bugs introduced by somebody and say he's a bad guy and we need to get rid of him. Okay, let's not go into that. So if you were to create a private branch for a lot of the software, or maybe all of the software, this is your private workspace. You've basically cloned everything so that you work in your own nice, comfortable environment. Okay? Actually, if it's your own private workspace, there is no checkout. You have everything, or the checkout is sort of implicit. There will be at some point in time the hard time of reconciling when you want to merge again. So we can use this also for staging areas. You could say, well, we have a special branch when in our private workspace we think we're done, we've done the unit testing, and we're ready to give it to the people for integration. So we will merge our private workspace with a sort of special branch that is our integration. And if you have a large complex team with multiple teams, you may have multiple staging areas. You may have one at the level of your own team, the 6 or 7 people working together, and there is another one that is common between Kiev, Moscow, and I don't know, Omsk, or wherever you have another office. So there may be another staging area, and maybe the people who are preparing the software for delivery with the customer, putting it in the installer, they have yet another staging area. So there's maybe waves of merging that occurs over time to integrate to larger and larger subsystems. If you have some very rigorous acceptance test, the people who do the acceptance test and might want to identify very specific baseline and freeze them for a long time. So they want to be protected from you delivering new stuff all the time. They don't want to be disturbed by the developers coming up with new things. But on another hand, during the testing, you may hit a wall. Suddenly there's a nasty little bug that prevents any further testing. So they need to do some emergency patch on their private testing branch. So part of the role of the project manager, by the way, and large organizations delegated to a CM specialist, is to define all the rules of the game. What is a baseline? How many baseline? How do we name the baseline? Who's allowed to have a private virtual space? When do we merge? What are the rules for reconciling changes?